says cranes are lifting a statue. Crane A is pulling with a force of 600 pounds at an angle of 35 degrees to the left of the statue. Crane B is pulling with a force of 750 pounds at an angle of 50 degrees to the right of the statue. Find the magnitude and direction of the resultant force. So, like I said, a force is just a vector. It has a magnitude and it has a direction, right? If you've ever taken a physics course and you've talked about force diagrams, that's actually what we're just about to draw. A force is just a direction and a magnitude applied to an object. So, first things first, let's draw our diagram. I'm going to draw it to the side because I want room in my problem. Okay. Now it says that there are two cranes, each applying a force to a statue. Where should we pretend the statue is, do you think? Hmm? On the origin. Yeah. We should pretend that the statue is on the origin. And it says that crane A has an angle of 35 degrees to the left of the statue. In which quadrant do you think we can draw vector that represents crane A's force? If it says 35 degrees to the left, what quadrant should I draw that vector? Yes, quadrant 2, right? If I'm thinking about the statue being here on the origin, to the left of that statue would be in quadrant 2. So this right here is 35 degrees. And this is crane A. Crane B, however, is pulling 50 degrees to the right. Where should crane B's vector be? Yeah, quadrant 1. The right of our statue is here. Okay. So it's asking us to find the resultant force. Remembering force is a vector. Also knowing that 600 pounds for crane A is crane A's what do you think? What does this number represent? If oh, if we know that there are two things that make up a vector, and we know force is a vector, there are two things that create a vector, magnitude and angle. So yeah, it's our magnitude. Good. Magnitude, remember, is just like size. So 600 pounds is the size of our force. And then 750 is the magnitude for crane B. All right. In order to find the resultant force, which we know, or we just learned, that the resultant force you can find by adding vectors together. What do we need before we can add these together? What do we need to know? But what's something we need to know? Yes, Abby, that's a good point. I definitely need to know my direction angles. Right now, these are, well, I don't even know what these are. Not bearings. They're just to the left and to the right. So to find the direction angle of A, what do you do? How can we find the direction angle of A? Which is just, let me, how do we find this angle? From 0 to our vector. Yeah, the first quadrant is 90 degrees, and then you just add 35, and you get how much? 125. That is the direction angle of it. What about B? We also need to find the direction angle of B. Right now it gives us this 50 degrees from north. We need to know from 0 to our vector. How can I get that? Yes, yes. 90 take away 50 will give us the angle of B. So that's 40. That is the direction angle of B. Now what? How do we add vectors together? What form do the vectors be in to add together? Component form. Are these in component form? Heck no. They're not in any form. We actually don't even know what they are yet. How do we find a vector given a magnitude and a direction? Yes, exactly. The magnitude times cosine of the direction angle, which we're working with A first. So our direction angle is 125, comma, the magnitude times sine of the direction. So we do in our calculator 600 cosine 125 negative 344.145. I'm rounding the hundredths so that 5 makes the 4 round up to a 5. And then I do the same thing for the y value, but I use sine. So I have 491.49. And yes, Abby, that's how we would find B, exactly. Uh, so B, the magnitude is 750 this time. Cosine of our direction angle, which is 40, comma, 750 sine of our direction 40. And then I do calculator, 750 cosine 40, and you get 504.53, comma, 42.09. Now what? Add them. Wonderful. So I'm going to add A plus B. And remember, when we're adding vectors together, we add the x values or a terms, and we add the b value. So here this becomes, and I'm just going to pull down. negative 340 plus 574. Forgot the plus. It's annoying. Plus, and I get 230. The reason I'm doing that instead of typing in is because if I type in, I would actually be rounding before my end answer, which is not. Then add my B values, 491 plus, oh gosh, I'm about to forget the plus again. And I get 3.5. Am I done? Look back at 2 minutes. All that this means, guys, with respect to the horizontal, just means that the direction angle starts to move, which we already know it does. So it's like not needed. We're not done because it actually asks us to find the magnitude and direction of the resultant force. So this means we're actually having to find the magnitude first of our force, our resultant force. How do I do this? How do I find the magnitude of our resultant? So yes, we need to use the formula square root of our A term squared, which is 230.39 squared plus our B term, which is 973.58 squared. And this gives us, let's see, square root of, and I'm going to go down, plus, and I get 1000.47. Now, this is a magnitude. What unit of magnitude had in this problem? This resultant force has a magnitude of 1000.47 pounds. Now I need to find my direction angle. How do I do that? Yeah, number 10 of our B value of our resulting force, which is 973.58, over the A value of our resultant force, which is 230.39. So I do inverse tan of the B value over the A value. 76.69 degrees. So all of that just to find two numbers.